Okay, let's continue now with our discussion of SQL or SQL. And to take stock of where we are, we had mentioned that this language called SQL has two broad divisions of commands, two broad sets of commands. One is called the data definition language. That's the set of commands that allows us to create the database structure. So there we had talked about creating tables, the columns of the tables, setting up primary keys, foreign keys, all of that stuff. All the little bits and pieces that are needed to set up the structure of the database. The DDL is the set of commands, the language that lets us define the structure of the database. And then we said that once the database structure is set up, we have this set of commands called the data manipulation language. That's another broad category of commands within the SQL language. And within that also, we sort of conceptually thought of two sets of commands. One set of DML commands, they change content in the database. And that's in the last lecture, we saw those commands. So these were commands like insert, delete, update. Okay, and then within this DML set of commands, there's a second subcategory, and this is just retrieval. The retrieval does not change the content of the database, it just extracts content, okay? And I think I also mentioned that between these two, this two subset, by far the largest majority of operations on manipulation operations on the database is retrieval. Once in a while we change content, we insert, we delete, we update, but most of the time we're doing retrieval. Hence, these next few classes are going to be devoted to retrieval, and there's really one DML command with lots and lots of options and variations, and that's the select and command. And we will see that command in all its glory and all its variations throughout the next several classes. So this is the command and its variation, all its numerous variations that helps us do different types of retrieval. So this will be a fairly, what should I say, sophisticated, involved grammar, since it can do so many things, lots of different things, lots of different kinds of retrieval. It has many variations and there are many nuances to it. So we'll take our time going through it. So the grammar can get involved. But before we get into those nitty-gritties of the syntax, let's first take a look at our good old vendor example and get a sense of what kinds of retrievals might occur in a database. What kinds of things might we be doing when we retrieve information from the database, okay? So we'll start off simple. So pick up the laser pointer here. So the simplest type of retrieval that we might want to do is extraction from one table, okay? So give you an example. Let's say I want a list of all my vendors. So this is my organization that's selling things to customers. So I just want a list of vendors. Who do I buy my products from before I sell them to customers? So here it is. I have one table. So from one table, I want to extract one column. So that's sort of a very simple type of extraction that you might want to do. One column from one table. All right. Another example of a very simple extraction retrieval you might want to do, that is just from one table, you might want to list all the vendors who are from Tennessee. Okay, tell me who are all my vendors from Tennessee. So you can see there's one vendor over here, another vendor here, 1, 2, 3, 4, 5. So there are 5 vendors from Tennessee. All right. So if I ask, please tell me who are all my vendors from Tennessee, I'm basically talking about extracting a few rows. So in my previous example, we extracted one column from the table. Here we're extracting a few rows from the table. So that's sort of the simplest kind of extraction that you might want to do, extraction from one table. Another example of an extraction from one table is that suppose I want a list of all the products which I sell that cost more than $100, whose price is more than $100. So I want to get a sense of what are all the expensive products that I sell. So I want a list of the products that cost more than, whose price is more than $100. So here, this would be the first product. It costs $109. Then there's another one here, and there's another one here, and the last one here. So there seem to be 1, 2, 3, 4 products. So this would be an extraction. I would tell the database management system through the command select that please get me all the products that cost more than $100. So I will be extracting a few rows from a single table. Okay, so that's one type, very simple type of extraction. Sometimes the extraction that you want requires you to access more than one table, right? For example, let me come over here. So I come to invoice number 101. So I'm at this table. And I want to know who's the customer who placed in this invoice number 1001. Who's the customer? What's the name of the customer? Okay, I know the customer code, but suppose I want to know the name of that customer that placed this particular invoice. Obviously, that information is not contained in this table. But how do I extract that information? Remember this concept of foreign keys. This customer code is a foreign key in invoice, which connects invoice back to customer. So I start from invoice number 1001. I find out the customer code, and I use that customer code to link back to this particular customer 1014. And once I've connected those two rows, I can go across and find out the last name and the first name of the customer. Okay, so this simple question of asking what's the name of the customer who placed invoice number 1001, that would require me to connect two tables. Okay, so we will see what is the grammar, what is the syntax in the select command that lets you hop from one table to another to connect multiple tables before you do your extraction. Okay, now the extraction can get much more sophisticated. Okay, so let's see a couple of examples of more sophisticated kinds of extractions. Okay, so for an example of a more sophisticated extraction, suppose I want to know the total dollar value of invoice number 1001. So what's the total value of that particular invoice? Now think of what needs to be done. This particular invoice, 1001, has two line numbers. There are two line items. Okay, so I need to start from this table 1001, come over to this line table using the foreign key, and that tells, so that I use the invoice number to find out, to know that there are two line items. And then when I look at each line, I have to multiply the number of units by the unit price, number of units by the unit price, and then add everything together. So this simple question, like, please tell me what is the total value, dollar value of invoice number 1001, that requires me to extract two rows. First of all, it requires me to connect two tables, and then it requires me to aggregate two rows. So I extract the two rows, and then I aggregate the value. So there's some computation that's required. Notice I didn't change the content of the database. I extracted information from it and then perform some arithmetic on it. So gradually you can see the more and more sophisticated kinds of queries that one can ask. All right. So the queries can get even more complicated. So suppose I ask, suppose that the question that I ask is, who are all the vendors? Give me the names of the vendors associated with invoice number 1001. Now that information, the vendor name, is contained only in that's the only place that I can find the vendor name. The only place that I can find the vendor name is the vendor table. So somehow, if I want to know the vendors who are associated, who supply the products associated with invoice number 1001, I somehow need to get from this table to this table to this table, and then finally to here. So what would that require me to do? I start with invoice, okay, and then I know that invoice number is a foreign key in line, so I use invoice number to connect line and invoice. Okay, then I look at this product code, which is a foreign key in line. I use product code to connect line with product. And then once I have connected these three tables, I look over to the vendor code here, and I use that to connect back to vendor. So I use foreign keys to connect one table to the second table, to the third table, to the fourth table. Once I've done that connection, then I can find out who are all what are the name of the vendors associated with this particular invoice. So it's a multiple step process, but again, it's an extraction. I have not changed the content of the database in any way. I'm just extracting different rows from different tables. But in this case, the retrieval is more complicated because I had to combine somehow the contents of multiple tables. So as we go through the syntax of the select command that we're about to start looking at, I will progressively introduce more and more sophistication in the grammar that allows you to do more and more sophisticated kinds of retrieval. So I hope these few examples have given you a sense of the range of queries that one can ask. There can be simple queries that work on one table. There can be a little more complex queries that require you to connect multiple tables. And then there can be even more complicated queries that require you not only to extract rows by connecting table after connecting table, but also to perform some kind of aggregation or arithmetic calculations on them. Okay, so we'll progressively see more and more complex retrievals, but let's start in a simple way. Okay, so this famous select, the DML command that used to do retrieval is the select command. And you can see all these different clauses. So in its full glory, the select command would have the word select. It would have a from clause, it would have a where clause, it would have a group by clause, it would have a having clause, and it would have an order by. So these are all the options. Think of a car which for which you can get many different kinds of options. So the select command comes with many different options as well. So these are all the different options. And let me just give you a high-level description of what these different parts of the command would do. And then we'll see examples gradually progressing from simple to complex. We won't see the full complex command in one shot right at the beginning. Okay, so any retrieval operation from the relational database starts with the command select. This is a reserved word, and it has a special meaning to the database management system. Just like you had update, you had alter, you had insert, you had delete from. So all those commands, they have a special meaning. Those words have a special meaning for the database management system. As soon as the database management system, such as SQL Server, as soon as it sees select, it knows you're about to do a retrieval of some form. Now, after the word select, what do you list after the word select? These are the columns that you want to pull out from the database. So remember that little example that we had. If I want to know the names of all the vendors, I would list vendor name as the column that I want to extract. Okay? So following the word select, you would list the columns that you want to extract from the database. Then you have the word reserved word from. There you list the tables from which obviously extractions need to be done from the table. You can extract from one table, as we saw in the example. You can extract from more than one table as needed. So after the word from, you would list the tables from which you do the extraction. Then the where clause specifies how you extract the rows. Okay, so if you are extracting, to remember one example that we had, I said, tell me the names of all my vendors from Tennessee. Okay. So I want to extract only the vendors who are from Tennessee. So I'm extracting some rows. All right. So in the where clause, you specify the conditions for selecting the rows from the tables. All right. And then group by would be used if you're trying to coalesce. Okay, so the example that I gave you a few minutes back was I had an invoice number. So I had this invoice number, and I wanted to find out the total value of the invoice. Those are kinds of circumstances where you might want to group data. And then let's the examples for having an order. I think you can guess what order by means, that you would sort the output in a particular way. We will see what having does gradually down the road. So for starters, we'll start from just these first two clauses, and then we'll progressively build up to more and more complex retrieval operations. Okay, but this is the select command in all its glory. So if you had a very complicated kind of retrieval, you might need to use all these different options of the select command. All right. So let's start simple, and we'll work our way up to more complex examples. Okay, even though you saw the select command in a particular syntax, let me just repeat that. So for the select command, you would start with the word select, followed by from, where, and so forth. So there's a certain order in which you write the command. Okay, but the order in which the command is executed, so the different clauses, what's the order in which they're executed? The first thing that's done is that the database management system tries to identify what are the tables from which to get the result. So the from clause is the one that's executed first. So going back to, even though it's written second, okay, the from clause is executed first. Otherwise, if you don't know what are the tables from which you want to get the results, and you're stuck, then you can't get ahead. The next clause that's executed is the where clause. You will see, and that's, remember a couple of minutes back I said the where clause tells you how to identify the rows that are to be extracted. Okay, so that's what's done next. First, I figure out what are the tables from which I need to extract information. The second piece is what are the rows that I need to extract from those tables. All right. Now, if it so happens that you need to get your information from more than one table, then of course the where part, to identify the rows from which you want to get the information, the where part will also contain grammar that tells the database management system how to connect the multiple tables. If you need to extract information from multiple tables, you need a way to tell the database management system through your command that this is how you connect the two tables. Okay, so the connection information will also be given here if you're getting your extraction from more than one table, right? Then after these two are done, the group by clause is executed, the having clause is executed, and the last clause to be executed is the select. In other words, the columns that you want to extract, that's what's identified last. Okay, so just to remember that we write the commands, write the different pieces of the select command in a certain order, but when it comes to execution, the execution is done in a somewhat different order. And I hope this discussion that we've just had makes it clear to you why we need to do the execution in that particular order. All right. So I can't talk about extracting rows until I first know what tables am I extracting information from. Okay? I can't do any grouping unless I have first identified the rows. So there's a certain logic to executing the clauses in a certain order, in this particular order. But remember that that the execution sequence is somewhat different from the order in which you write them when you're actually issuing the command. Okay. So we will start simple now. As I said, we'll start with the simplest select statement, and then we'll gradually build up to more complex query. So coming back to what I had mentioned. So I mentioned that this is the select command in all its glory, with all its different components. Okay? But the simplest version of the select command that you can have is select from, and that's what we will look at next. So the minimum that you need to specify in order to do an extraction is select from, meaning what are the tables from which you need to get information and what are the columns you need to show. So let's see an example over here. So here I have a table called course, and this relational schema over here tells me that this table called course has three attributes, has three columns, and the primary key is course name. And here you can see the actual records for this particular table, and the extraction that I want to do in words, the way I express the operation that I want to do the extraction is show me all the columns from the table course. So I basically want to see the whole table, and the syntax for it is select star. Star is a shorthand for all the columns. From course. Remember the sequence that we had, the grammar. After the word select, you list the columns that you want to see. Then you follow that with the word from, and you list the table from which the extraction, table or tables from which the extraction is being done. So to go back to our example, what we are telling the database management system is the star is a shorthand for the names of the columns. Okay, so I'm saying select all the columns from the table course. Now notice there is no where. There is no where clause. Okay? If there is no where clause, that means you're selecting all the rows. You're not selecting any particular row. Okay. So this particular query that you're seeing is the simplest type of query that you can have. You're extracting information from one table, and you're extracting the entire table, so to speak. Okay. So the star, the symbol star, is a shorthand for all these columns. Okay. What you also could have said, and this would be perfectly fine as well, is you could have said select, and given the names of the columns, you would have said course num, course name, credits, from. You could have written this as well. And this, the way I've written this in ink right now, this would have followed the grammar precisely. So I would say select and list all the column names from course. Now, why is this shorthand there? Why is this star there? You can imagine a table that has 15 columns. Okay? And if you want to see the whole table, it's a headache to write all these 15 names over here, the names of each of the columns. So if your intent is to extract all the columns from a particular table, then this star is a convenient shorthand for doing so. Okay. Now here is a slight variation of the previous query that you just saw. Just for as a reminder, what did we have previously? We had said if I want to extract all the columns in this table, the grammar that we had, the syntax was select star from course, and we said star is a shorthand for all columns. Now notice the slight difference with this syntax. It says select course dot star from course. So this is a little bit here is extra. This expression here, course dot star. So if you think of the two pieces, this is basically. So this is basically, if I parse this, this is table dot column. That's the format for it. That's what course dot star represents. This is what is called a fully qualified name, or an identifying. So this is, I have identified the column fully. Okay, so this is a safe way to express the column, because if there is more than one table from which you're extracting data, then if the same column name appears in two tables, then the database management system can get confused. So if there is no ambiguity in this case, I'm extracting information from just one table. So if I just give the name of the column, there is no ambiguity, and I don't need to write out all this fully qualified name. But this is a safe practice to do. Okay. So I hope you see the similarity and the difference between the previous example and this one. We're extracting the same information. We're extracting data from the whole table. In one case, I just wrote select star from course. In the second example, I'm telling the database management system, it's not just any star, it's course dot star. It's from the table course. So this is what's called a fully qualified name. So that's why you see identifying columns fully. The way you identify a column fully is by saying table dot column name. That's the way you identify a column fully. And there will be occasions later on you will see where it is absolutely critical to identify a column fully. And if you don't do that, then confusion will arise. But so we wanted to show you an example of what we mean by a fully qualified column name. Okay. Now let's look at this same query but with a slight twist. Okay, so just for your memory, this was the query that we had. Select star from course, and we know what that does. Let's look at our example. What's different over here? The only thing that's different here are these two words, as C. So it says select star from course as C. What's the whole purpose of doing that? This is what is called an alias for a table. All right. So sometimes table names are long. If you're trying to write a fully qualified column name, you would say table dot column. So it helps sometimes to have a shorthand for a course. So have an alias. So this C, this letter C that you're seeing, is an alias for this table called course. Once I have specified an alias, I can use it in many different ways. For example, the previous query that we saw, this select course dot star, instead of writing that, once I have set it up this way, I could write select C dot star from course as C. Okay. So once I have told the database management system, hey, I have an alias for this table name, then I can use that alias wherever the table name has to appear. So this is what's called aliasing the table, and it's really just a shorthand. It avoids having to type too much, and the commands can be more compact and more readable. So it's just a shorthand for referring to a table. Okay. So here is the repeat of the example that I just showed you a minute ago. So once I have specified this alias C for the table course, then I, instead of saying select course dot star, I can say select C dot star from course at C. So this particular query, this one and this one, would give you exactly the same output. Okay. Okay, in the examples that we've been seeing so far with the select command, we have extracted the entire table, that is all the columns in a table. So just as a reminder, here was the course table, and we had different variations of this command, but basically select all the columns. So we say select C dot star from course as C. So we discussed some variants of this, but the essential element was we were extracting all the columns in the table, and that's where the star came from. Okay. So slight change here. So suppose I want to extract specific columns. Here is our table. Our table consists of 3 columns, and I just want to extract 2, course number and course name. So here is the grammar. I have select followed by the names of the columns that are to be extracted from course as C. All right. C was the alias. Remember, we could have aliases for the table name. We could have aliases for the column names, depending on what's convenient for us. Aliases basically help us save on typing. For this particular example, since we are dealing with only one table, I could just as well have written select course number, comma, course name from course. Okay, so I could have written the following. Let me pick up the pen here. And so for the same command, I could have written it this way. I could have written it as select course num course name from course. I could have just written that. Okay, and I would have gotten exactly the same result. But this variant over here, just getting practice with using the aliasing. All right. And the difference between course num and C dot course num, this is just being doubly sure in this case, since we are extracting data from just one table, there cannot be any ambiguity as to which column I'm referring to, but such ambiguities can arise if the extraction is from multiple tables at the same time. Okay? and if two tables have to have the same column name, have two columns which have the same name, then this can cause confusion. That's where the fully qualified name would be helpful. So this select statement and this select statement would give you exactly the same results, and you can see what the output looks like. You have the two columns from the table that have been extracted. Okay, so let's continue with some more examples now. Again, a slight variant of the select command is pretty much the same, rather not quite the same. It builds on this previous example. In the previous example, we had extracted two columns from this table course. Now we want to extract all three columns. So remember, in this table, the three columns are course number, course name, and the credit hours for the course. Okay, so we want to create a third column, which is derived from credit. So we are assuming that for every credit hour that a course has, a student needs to study 2.5 hours outside of class per week. Okay. So suppose I want this third column to reflect the number of study hours per week that is associated with the course. So here I would say select c.course_num, c.course_name. So these first two are essentially the same as the last select statement. And now we add this third column. But notice that this third column, it doesn't say credits. It says credits times 2.5. This is what is called a calculated column. Okay. That's another sort of a derived column. Notice I'm not changing anything in the database. Again, when it comes to retrievals, you're not changing database content. You're just maybe presenting it differently, summarizing it, and so forth, but nothing inside the database changes. So here in the output that the end user receives, they will see this derived value. And another example of a derived value is if you want to, let's say you made a purchase and the tax that is to be calculated is the 6% of sales and so forth. So the tax dollar amount would be a derived value. So this is a derived value, and unless I give the third column a name, what SQL Server will do is it will give the name of the column as this calculated heading. So it will say c.credits times 2.5, okay, or it will give a name that it has cooked up itself. To be on the safe side and to make the output more readable, you know that the word as stands for aliasing, is used for aliasing. So this command is basically telling SQL Server from the table course, pick out the column called course number, pick out the column called course name, and for the third column, produce a derived column, which is 2.5 times the credit hour, and relabel the heading for that column as weekly study hours. Okay, so this is the aliasing for the third column, and you can see the output. So here is course number, it shows up here. Course name is the heading for the second column, shows up here. And this third column, which is the derived column, has this aliased heading. This weekly study hour is what shows up here. So this is an example of an extraction that requires a calculation based on something that was based on some values that were extracted. Okay. So in the previous examples, some of them, you saw how to do aliasing for table names, and the point that we made was aliasing for table names saves us on typing on more complex queries. So in the previous examples we saw, we had an alias for the table names. It's from course as C. So once you have that alias, anywhere you need to refer to the table name, you can use the letter C instead of having to type out the word course. You can do the same thing with columns. Okay. So here we said select c.course_num. Course_num is the heading, is the name of one of the columns, but it doesn't look nice. It's not a full name. So we could say, hey, when you produce the output, relabel this column as course number, the full thing we write out. Similarly, for course name, we alias it as course space name. Now, again, we are not changing anything in the database. If you were to take a peek inside the database, the two columns would still have these two names, course num and course name here. So this is an example of where, just like we had an aliasing for the table name, we now have aliases for the column name. And you can see in the output, this relabel, the course number, that's what the name shows up as the name for the first column. This is what shows up as the name for the second column. And here is the alias, the name for the third column. So this is an example of aliasing for columns. Because why is aliasing for columns helpful? Because typically inside the database, columns often have sort of abbreviated names. And when you're producing the output, it might be more meaningful to have full headings or full names for the column. So that would be a reason for aliasing the columns. Okay. So another variation of the select clause. Here's the select statement, and this is the select clause. So after the word select, we have the names of the columns that we want to extract. That's the format that we have seen so far. Then we have the reserved word from, and after the word from, we list the tables from which the extraction is to be done. So here is select from student, and we produced an alias for we have written the alias for this table as S. So the table called student is now referred to as the table S. So we are saying from S, pick the column city. Okay. So basically the question in narrative form would be, show all the different cities that my students live in. So I have 4 students in this table, and if I look at the cities that they live in 3 different cities. Now, if I execute this select statement as is, then the output that I would get is this column chopped out by itself, this column sliced out vertically. So I would get an output that looks like this: Fairfax, Arlington, Fairfax, Shankly. So Fairfax is duplicated twice, right? So I don't need to have those duplicates because the question said, please list the cities in which my students live. So if you have 500 students, maybe 400 of them live in Fairfax. I don't want to see the value for Fairfax show up 400 times. So if you want to remove duplicates from the output, the additional qualifier that you add is the word distinct. So you say select distinct s.city from the table S. Remember, S is a proxy or an alias for the table student. Now once you say distinct, duplicates are removed. So these 2 Fairfaxes get collapsed into 1, and you now have this output of 3 cities. So the answer would be, all my students live in these 3 cities. So the qualifier distinct removes duplicates from your output. Okay. Okay, next we will move into a topic that we have introduced before. So very first, at the beginning of today's session, we went to this vendor database where we were looking at various examples. Let me see if I go back to that particular example here. Yes, so when we were discussing, when we started discussing the select command, I gave you examples of such questions where you might want to, where you need to combine information from different tables. All right. For example, if I have invoice number 1001 and I want to know the name of the customer who placed that invoice, I can't answer that question based on this one table alone. So what I have to do is, from invoice, I need to use the foreign key, the customer code, to link invoice back to the customer table. And from here, I would pick out customer number 10014. And from there, I would find out the name of the customer. So depending on the question, you may need to combine or connect 2 or more tables. Okay. And the SQL, the select operator that's used to do that connection, is called a join. And there are several different kinds of joins. So we will spend a little bit of time on the join operation. Let me get back to join. I don't want to cross it. Okay. So the topic that we are about to dive into is the topic of join. And conceptually, just remember that a join, when does it arise? It arises when you're trying to connect 2 or more tables. So in order to get whatever answer that you're looking for, you need to combine the information in more than 2 tables. Okay. And you do that through the join operation. Okay, so the information that you want is not contained in any one table completely. That's why we need to combine information from different tables. So the operator that's used to do that is called a join, and as it so happens, there are different varieties of joins. So we will look at each one of them in turn. Okay, so for context, let's look at this particular setting over here. This is what the database looks like, from which we will be doing extraction that will require the combining of information from multiple tables. So this relational database has 3 tables in it, one called course, one called faculty, and the other called course offering. Based on our discussions that we've had in previous lectures, I hope you can identify this course offering table as an intersection entity. There is a many-to-many relationship between course and faculty, and this course offering is showing up in the middle. It has a composite primary key, course number and faculty ID. The primary key for course is course number. The primary key for faculty is faculty ID. All right. Now let's take a peek into the records themselves that are there. So if I look at this course offering, this first course offering have MIS 301, and it is being taught by faculty 11111. Okay. Similarly, I have another section of MIS 301 that's taught by a different faculty member, and that's 22222. Then I have another course, MIS 310, which is taught by that same faculty member, 22222. So these arrows that you're seeing link the different to the 2 different tables. So the linkages are based on a foreign key. Do you see? Excuse me. So this table, this course offering table, has a composite primary key. The primary key is the combination of course number and faculty ID. Okay. However, course number by itself, so in the course offering table, the column called course number by itself is a foreign key that links this table to the course table. Similarly, faculty ID is a foreign key that links this course offering table to the faculty table. Okay? So the only way that you have to connect one table to another using the join operation is using foreign keys. Foreign keys, you have seen this when we were talking about the data definition language. Foreign keys allow you to connect one table to another, and that's the mechanism that you have available to you to jump from one table to another. Now, there are a couple of other aspects to this database that I also need to point out. Now, if you look at MIS 302, this is a course. But notice that nowhere does it appear in the course offering. There is no course called MIS 302 in the offering. That simply means this is a course that is on the books, but is not being offered. That's perfectly normal, right? Similarly, you have MIS 410, which is among the list of courses that could be offered, but it is not being offered now. So MIS 410 doesn't show up in the course offering. Now, a similar situation here, you have this course MIS 320. There is no faculty member who's been assigned to that course just yet. So the second component is blank, is null, rather, I shouldn't say blank, is null. So I have a course offering which is not assigned to a faculty yet. Lastly, if I look at the faculty table, I see a faculty member, David King, who has not been assigned to any course offering, has not been assigned to any offering. Okay, so there are courses that have not been offered. There are faculty who are not offering any courses. So this is the scenario with which we are dealing with, and we need to keep this scenario in mind as we work our way through joins. And as I said a couple of minutes back, there are different types of join, and depending on the type of join that you are using, you would get different results for the same 3 tables. Okay, so let's proceed to explore the join operation in a little more detail. Okay, first the syntax. How do I actually write the join? So here's the syntax. You would say select such and such. So here you have the from clause. So in the from, remember the from clause lists the tables from which you're going to do your extraction. So here's table 1, here's table 2. So when you do a join, each join combines records from 2 tables. Now, if you're going to join 3 tables, you would have to do 2 separate joins. Okay, so for any one join, you're only going to combine 2 tables. Okay, so the way you express that to the database management system, you would say select such and such from table 1, and T1 is just an alias for table 1, and then you would specify the type of join. All I've said up to now is that there are different types of joins. We will see what those names are for the different types of join, but you would say from table 1, what type of join it is, you would specify, and here's table 2. Okay, so these are the 2 tables you would join, and then you would follow that with the word on. So this vendor example that I discussed just a couple of minutes back, I went from invoice to the customer table. Remember I said you use the foreign key to jump from one table to a foreign key connects 2 tables together, right? So you would need to specify the connecting column in order to go from one table to another. In order to join 2 tables, they must be joined on matching values of a specified column. Okay. So here's the syntax in its full form. You would say from table 1, what type of join you want to do. Here's the second table involving the join. On, and then you specify the 2 columns that must match from the 2 tables. You see T1.column1 equals T2.column2. So here are the 2 tables, and these are the 2 columns that must match. So column 1 from table 1 and column A from table 2 must match. So that's what you're telling the software, that in order to match table T1 and T2, look for these 2 columns and you must match them based on those 2 columns. So we'll see what matching means in a moment, but this is what the basic grammar would look like, the syntax would look like when you write things out. Okay. So now let's proceed to see in detail how you connect related tables records. So basically all we said so far is we use the common fields, the foreign key, to connect the 2 tables, but we haven't really gotten into the details of how the records from the 2 different tables are matched and actually joined. That's what we're about to look at next. Okay, so here we have these 3 tables whose structure we just discussed a moment ago. So let's say I want to join faculty and course offering. Remember, we can only join 2 tables at a time. So let's say I want to join faculty and course offering. Now the common column, the column that matches these 2 tables is faculty ID. These are the 2 columns, the foreign key and the primary key. This is a foreign key in the table course offering. This is a primary key in the table faculty. We'll match based on those. Okay. So what would be the grammar in which I would state this? I would say from faculty. Okay, this is the table, and F is just an alias for faculty, the table. Then I would specify the join type. I still haven't told you what are the different types of join. We will see in a few minutes. There's an inner join, outer join, full join, all the different kinds of join. So I would specify what type of join it is. Here is the second table, this course offering. And notice how the alias is helpful. Now, course offering is a long name to type. So I'm saying that, hey, I'm going to shorten this to O. Whenever I need to refer to course offering, I'll use the letter O. On. So the word on is followed by the matching columns. So we're saying on F.faculty ID. So here's F.faculty ID. That's this column. Okay. Is equal to O.faculty ID. So here's O is this particular table. That was the alias for course offering. We just saw that. So O.faculty ID. That's here. Okay. Now with this example, I hope you see the value of using fully qualified column names. Okay. If I simply said faculty ID equal to faculty ID, it may not be obvious. I have 2 tables, and in these 2 tables, I have columns with the same names. So just to be absolutely unambiguous as to which column I'm referring to, as soon as I say F.faculty ID, I know I'm referring to this column. And when I say O.faculty ID, I'm referring to this particular column. Okay. Now, just for the sake of discussion, suppose, let me get the pen here. Suppose this particular column, okay, instead of being called fac ID, it had been called FID. Okay, it's still a foreign key. Okay, so in that case, I would say that the way I would write this particular command is I would say f dot faculty ID equals o dot FID. So that's the name of the column that I would use. Okay, so I hope you're getting a sense of the grammar, how you would write out the sentence. I haven't yet shown you how the matching of the records would be done once this particular command is provided. That we will do in a little bit. But all I'm doing up to now is showing you that how to write the join operator. So this is the syntax that would be used to join these two tables, faculty and course offering. Okay, so we'll move on from here now. In a similar manner, if I wanted to join course with course offering, if I wanted to join these two tables, the common column between these two is course number. Course. Now notice that the names are different here, isn't it? See, COURSENO, that's the course number. That's the name of the column in the course table. And in the course offering table, the name of the column is COURSENUM. So even though the names are different, conceptually, these two columns represent the same thing. They represent the course number, isn't it? So the joining is done based on common fields, the foreign key. This particular column is the foreign key in course offering. So here is how I would write the join. So I'm about to specify or tell the software, the database management system, please join these two tables. Okay. So I say from course C. So this is the first table I want to join, and I give it an alias C. Then I specify the join type. You will see in a minute. I'll say inner join, outer join, left join, right join, all different kinds of joins. Follow that by the name of the second table that's involved in the join, which is course offering, and I proxy that with the letter O. I alias that with the letter O, and then I complete the statement by saying, please join these two tables based on these common fields. Okay, that is C dot course number, C dot COURSENO equals O dot course num. This is the foreign key equals the primary key. Okay, so that's the syntax that you would use to join these two particular tables, course and course offering. So now let's look at the different. I've kept this hanging up to now. We just said join type in the middle, and I just rattled off a few names. Let's take a deeper look at what are the different types of joins and how, depending on the type of join that you're using, the matching of the records would be different. That's what we're about to get into a more detailed discussion about. Okay, so there are these four different types of joins. One is called the full join, one is called the left join, one is called the right join, and one is called the inner join, or simply the join. Most of the time, I would venture to say maybe 90% of the time, when you join two tables, the type of join that you're doing is the inner join, and that's why we only say join. Okay, so this last one is by far the most common one, but depending on the business application and the type of output that you're looking for, you may need to use these other types of joins. Okay, so remember in the examples that we saw, that we wrote, let me just pick one of these. When you write a join statement, there is always a first table, and then you specify the join type. Now you know the four different join types. You would either say inner join, left join, right join, or full join over here, followed by the second table. So there are always two tables involved in a join. There's the first one and the second one. So just keep that picture in mind, the structural picture in mind, as we walk our way through the different types of joins. So let's take the full join. How does the full join work? The full join produces all records from both tables, both related and unrelated. So what do we mean by related and unrelated? Let's say course and course offering. Okay. MIS 301, this record and this first record are related. Why? Because the foreign key matches the primary key. Similarly, course number, this MIS 301, is related to the second record as well in the course offering table, because here also the course number is MIS 301. So this record is still also related to the second. Now notice that this third record in course offering is not related to this MIS 301 because the course numbers don't match. This course number and this course number don't match. Similarly, MIS 320, this particular record, this last one in course offering, is not related to anything, is not related to this first one. Okay, so that's what we mean by related and unrelated record. So MIS 310 here is related to this record over here because the primary key and foreign key match. So in a full join, we will actually go through the details, actually produce the output in just a couple of minutes. So in terms of definition, a full join produces records from both the tables, whether they are related or unrelated. A left join produces all records from the first table and only related records from the second table. A right join produces all records from the second table and only related records from the first table. And an inner join only produces related records from both tables. Okay, so if I were to do an inner join of course offering and course, if I were to join these two tables with an inner join, then MIS 410 wouldn't appear in the result. This particular guy would not appear in the result because they're not related. So only related records would show up in the output. Okay, so I think it helps to see a more detailed example, but we just started with a definition of the 4 different types of joins, and then we'll see how each one works by looking at individual records. Okay, so a little more detail before we look at the example. So only 2 tables are joined at a time. We've already mentioned that. How does the joining actually work? Okay, so records from the tables are joined on identical values. All right, so you start from the first record in one table and then go through all the records of the second one and see where the match occurs. Okay, for the course number in this case. All right, and then pick only the ones, pick only the matching pairs. Okay, so how do I decide what columns are included in the result table? All columns from both tables are included. Okay, so if I were to join course number and course offering, then in the result I would have 4 columns. I would have this column, I would have this column, I would have this, and I would have this. Okay, so let's again continue with this discussion and see how the records in the output are produced. Okay, so let's start with the full join. Remember that we said 4 types of joins, so we'll start with the first one, the full join, sometimes also called the full outer join. So here's the query or the extraction that I want to do in Word. I want to see all the info on faculty and offerings. I want to include related records when available, and I want to include unrelated records as well. Okay, so here are the 2 tables that are involved in our query. One is faculty and the other is course offering, the intersection entity. So here is the statement, the SQL statement that we write, which is select f dot star o dot star. So what is f and what is o? I don't have a table called f, I don't have a table called o, but by now you know that these single letters are very typically used as aliases for faculty name. Where do I find the aliases? The look of the next statement says from faculty, and you have the letter F next to it. So F is the alias for faculty. I could just as well have said faculty as F. Okay, so that would be a full, complete, detailed way of writing that. But I can also say faculty space F. So F is a proxy or an alias for faculty. O is an alias for course offering. So F dot star, comma, O dot star. That means pick out all the columns in faculty table and all the column in course offering table. That's what these 2 things mean. F dot star and O dot star, all the columns from both tables. Now the second piece is what actually connects the two tables. Okay, so we say from faculty full join course offering. So I'm telling the software that please join these two tables. You can only join two tables at a time. So I'm telling the software, please join F with O, and the type of join that I want to do, out of the 4 different types of join, I want to do a full join. And any join is based on matching values of the columns in the two tables. So I'm saying on f.faculty_id equals o.faculty_id. So I'm saying do the matching based on equality of values for these two columns, faculty ID in the faculty table and faculty ID in the offering table. So this is the full command. You can see that at this point, just by looking at this the select statement, I have written the 4 columns. There's the first column, second column, third column, fourth column. Okay, so fact.factID, f.factName, o.course number, o.faculty. Okay, so the number of columns in the output of a join is always one table. Okay, so how many columns does that output have? It has all the columns of the two tables being joined. In this case, the first table, faculty, has 2 columns. The second table being joined has 2 columns. So the output has 4 columns. Okay, so f.faculty_id. This guy is this column. f.factName in the output came from here. It's from this faculty table. o.course number in the output, this column, came from course number in the offering table. And o.faculty_id came from faculty ID in the offering table. That's what the o.faculty_id. Okay. So I know the columns now. Now I have to figure out what are all the rows. When I join the two tables, how do I get the rows? Okay. So we'll continue with filling out this particular table, and let's see how that works out.